So one way that you can think about using this wait notify is in what's called a producer-consumer relationship. So we're going to start by using this producer-consumer relationship using wait notify, and then we're going to also look at how it would work using one of the more complex classes that we would actually use to get this kind of behavior. So a producer-consumer relationship represents some application that has shared data between two kinds of threads, a producer thread and a consumer thread. The way you can think about this is that the producer thread creates some kind of data or item or objects or whatever it is, and the consumer thread uses that data, item, or object, or whatever it is. So for example, a producer thread might read in an object from a database and then give it to a consumer thread to process. A producer thread might read input from a user and then hand it off to a consumer thread to be analyzed. So you kind of have two different threads working, one that's getting the data, producing the data, creating items, creating data, creating objects, and then one set of threads that are using those objects, analyzing them, processing them, doing whatever they're doing. Okay, so this producer consumer relationship is a really common setup for lots of different kinds of applications. Coordination between these two types of activities is essential, right? The consumer can't use an object unless it's been produced, so there has to be something there to analyze. So the consumer has to wait if there's nothing ready. And the producer can't create an object, can't create an item if the consumer is still busy or if they haven't taken the old item. So the producer might have to wait until there's space for that new item to be consumed. Okay, so this is kind of the general relationship, and we're going to start by looking at this relationship, how to support this relationship using wait notify, and then look at a better way to do it. Okay, a more modern way to do it, I should say. So we're going to look at an example that uses a number box. A number box is just a simple class I wrote designed to hold a single number that can either be filled or empty. So the box can be filled and it'll hold a number, or it can be empty, at which point it means there's no number there. And the idea is we're going to have a producer thread that's creating these numbers and a consumer thread that's using the numbers. Okay, the consumer thread has to wait until there's a number to be taken out of the box, and the producer thread has to wait until the box is empty to put a number in. Okay, so again, this is a really simple example, but think about in a larger setting how this same construct, this same setup could be used in any sort of producer-consumer relationship. The idea is that there's a fixed number of places for objects or items or data to be, and the producer is creating that data, putting it there. The consumer is taking that data, doing whatever it needs to do with it, but each one of them might have to wait, right? The producer might have to wait till there's room to create a new object. The consumer might have to wait until there's an object ready to be used. Okay, so let's take a look at these classes. So here is the number box class. Pretty simple. It just has a number and a Boolean status of whether it's filled or not filled. So there's a get number from the box. That's just a synchronized method that retrieves the number and then also marks the box as unfilled. So that Boolean flag just represents whether there's a number in the box or not. Similarly, there's a put the number into the box, a synchronized method that just takes in a new number, puts it in the box, and marks the box as filled. And then a method to just retrieve whether or not the box is currently filled, and a toString. So pretty simple little class. Now, here is our producer thread. So this is our producer thread implements runnable. It's associated with a number box, and we're just going to set this thread up to run 10 times. You could alternatively create 10 different producer threads. I'm just doing it this way to kind of just show you a different way of setting it up. This particular producer thread is going to, again, it's going to execute its run 10 times. So we have a loop 10 times. With each pass of the loop, we're going to synchronize on the number box. So this block of code is going to be synchronized on that object, meaning when the producer thread gets to this part, it has to acquire the lock on the number box. So it has to own that lock before it can enter this block of code. And then here is our condition. So while the number box is filled, that means the producer has to wait. So remember, the producer thread is the one that's generating numbers to put into the box. But if the box is already full, remember our box can only hold one number at a time. So if the box is already full, the thread just has to wait. Okay, so here we have our loop. Well, the condition that I'm waiting for is not true. I need the box to be empty and the box is full. So I'm just going to print out so we can watch this trace. I'm going to wait. And again, I'm waiting. I invoke wait on that object that the lock is associated with. this in turn releases that lock, right? This will release the lock on the number box. Now, when I get notified, I'll come back around, check again, and if at that point this condition is false, so if the number box is now empty, I will exit the loop and I will generate a new number, put it in the box, and then I'm also going to notify other people, other potential threads. Okay, and we'll look at the consumer thread in a moment. Then I have just a sleep here just to put our threads to sleep so we can kind of watch the interaction go not all at once. So that's the only purpose of the sleep, is just to kind of, it's more like make it more like an animation. So here is our consumer thread. Again, the consumer thread is associated with the number box, and it's also going to do its work 10 times. It's also going to be synchronized in the number box. So here we're going to acquire the lock to the number box, and then we're going to say here I'm checking while the number box is not filled. So if the number box is empty, I have to wait. Right? So this remember, what's in here is the condition that you need to be true, and you check well it's not the case. So you check well the condition I need to be true is not the case, then I come in here and I wait. Okay, and then as soon as I get notified, I check my condition again, and if now that condition is true, my while loop will exit and I'll come down here and I can do the work. So for the consumer thread, what I'm doing is I'm getting that box, that number from the box, and then of course I'd be processing it, which I'm just having a print line, and then I notify again. So essentially you have both the producer and the consumer threads waiting and notifying, because when the producer puts a number in, it notifies to say, okay, any consumer threads that have been waiting, I'm notifying you that there's data there. And then when the consumer takes data, it says, okay, I'm notifying so that any producer threads that were waiting, there's space available for you to create new data. Okay, so this idea is it's sort of like this back and forth, this kind of dance between the producer and the consumer, waiting and notifying, waiting and notifying. Okay, so let's run this program. So here I just create my number box, I create each one of my threads, and I start them up. And here you'll see the producer adds a number to the box and goes to sleep. The consumer retrieves that number from the box and goes to sleep. And then all right, well, we'll just let it kind of run. Here you can see for each one of these, here the producer is waiting and then retrieving and sleeping. And actually, I'll just let this finish, and then we'll go back and watch it. Watch the trace through, but you can kind of see it as it's, and when you run it on your own machine, you'll be able to actually kind of watch it as it's running. Okay, so here again, the producer added a number to the box and then went to sleep. The consumer retrieved that number from the box and then went to sleep. The consumer woke up first. Once the consumer woke up, the box is empty, right? Because the producer is still sleeping. So the consumer waited. So it entered that wait. Then the producer woke up, it added a number to the box, and then went to sleep. Now, in adding the number to the box, the producer sent out a notification. So that would have made the consumer come out of that waiting state. It'll retrieve that number. Consumer went to sleep. In retrieving that number, it again sent out a notification, right? So when the producer woke up, it was notified and added a new number to the box, then went to sleep. And then when the producer woke up, the consumer hasn't retrieved that number yet. The 14 is still in the box. So the producer just started waiting, right? It just started waiting. So you'll notice that not all the trial numbers are printed out, because sometimes the producer doesn't have to wait. Sometimes when it wakes up, the box is empty, so it can just go right in and fill it again. But sometimes it wakes up and the box is still full, so then it needs to wait. Okay, so the idea again here is this sort of handoff of control, this back and forth between waiting and notifying. Waiting for the consumer is waiting for data to be available. The producer is waiting for data to be needed, kind of a thing. Okay, and they do that again with invoking wait and notify on the lock object. So all of this, all of this is happening inside a synchronized block. We're synchronizing on that object. And again, when you invoke wait, you're releasing the lock to that object. And then when you get notified, you have to then again, I don't want to say wait because you're not talking about the wait method, but you again have to be taken out of the waiting area until you can acquire the lock, because only one thread can have a lock at a time. Okay. So this is an example of representing this producer-consumer relationship with hard coding in calls to wait and notify. Now, in reality, like I said, You won't do this. Most people do not use directly wait and notify anymore. They've been in the language for a very long time, but there have been some much more efficient ways and easy ways of getting the same behavior that have been introduced. So there's a great quote in the Effective Java book by Joshua Block that using wait and notify directly is like programming in concurrency assembly language, right? This is like super, super fine grained, and we don't need to do it anymore. So there is seldom, if ever, a reason to use wait and notify in new code. So it doesn't mean that you might not see it, or you might not be, again, asked about it on an interview. But in reality, if you're writing new code or if you're kind of modifying newer code, you're probably not going to be using wait notify. Instead, you're going to be using high level, this should say constructs, and classes, one of which is blocking queue. So blocking queue is an example of a class that's used in concurrent programming, and it can very easily and cleanly support this idea of a producer-consumer relationship. So the blocking queue is, again, a special queue. Basically, it forces threads to wait for a non-empty queue to retrieve and wait for space to be able to add. So it exactly is designed for this producer-consumer pattern, okay? This idea that if you want to take something off the queue, you might have to wait for there to be something there. And if you want to put something on the queue, you might have to wait till there's space. Now, there's essentially 4 versions of adding and removing from the queue, and each one of them takes a different action if what you want to do can't be handled immediately. So the actions that are possible are throwing an exception, returning a special value, blocking, or eventually just timing out. So, for example, the example we were just looking of wait notify is essentially represented by this blocking action. If we use the methods put and take, what that means is that if you try to add something to the queue with put, but there's no room, the thread that's doing that put, that add, that insertion rather, will just wait. Just like we just saw with the wait notify, it'll just wait until there's space. And if you try to do a remove using take and there's nothing there, the queue is empty, the remove thread will just wait. It'll just wait till there's something there. Okay, so this blocking version is the analogous version to the wait notify. But if there's a different behavior you want, so for example, you can actually use add and remove these methods. If you're trying to add to a full queue or remove from an empty queue, they'll throw an exception. So that might be the case that you want. There's also offer and poll. These will return a special value. They'll return essentially null, or I believe, let's see, we can take a look at them. So offer, returns a Boolean. It will return a false if you cannot add to the queue. And poll will return null if there's nothing in the queue. Okay, so return a false or a null. And then you can also have these timeout versions. So this is like offer and poll, only it waits a certain amount of time before returning that false or that null. Okay, so you pick these 4 versions, use these 4 versions of inserting and removing depending on what you want the behavior to be. So we're going to first just look at this blocking one because that's going to be the analogous class to what we just wrote with wait notify. So let's take a look at another version of producer consumer. And I've called this one BQ producer for blocking queue, BQ consumer. So here's our producer thread. Instead of using my made up number box class, I'm just going to use a blocking queue. So I'm just going to actually use the class blocking queue. And here's my constructor. And then inside my run, all I do is I put the number in the queue. And that's the producer adding it to the queue. And then I go to sleep. So it's a lot simpler than what we did before. There's no direct call to wait and notify. There's no extra checking the condition. I don't need to check to see if there's space in the queue, because if there isn't, queue.put will just wait. It'll just wait till there's space. That's what the blocking version does. That's what put does. It just says if there's no room in the queue, hey, just wait till there is. And you'll just be kind of stuck there, waiting for there to be room. Okay, so this is kind of all that wait notify stuff is happening behind the scenes, and it's all built into the queue itself. For the consumer thread, again, I have this queue as instance data, and I'm just going to go through and I'm just going to take. And again, there's no wait, there's no condition, because if the queue is empty, the queue.take will just wait. It'll just wait till there's something there. It'll just get blocked on this line and wait. Okay, note that this is not inside a synchronized block. So we're not synchronizing on the queue. We don't need to do that. All of that synchronization is built into the blocking queue class. Okay, so you can kind of read the, you can read the introduction here. There's a great introduction, and there's a little, there's a little example here of using this, but essentially, you don't need to synchronize on it, and you don't need to directly wait because all of that functionality is built into the blocking queue for you. So it's much, much simpler. Okay, so let's run this. Now, when I create my blocking queue, blocking queue is, you can see here, it's an interface, so I can instantiate it, but there is a implementing class array blocking queue and linked blocking queue. So if I took a look at the array blocking queue allows me to specify, or actually requires me to specify, a capacity. So I have to say how big the queue is. If I wanted to directly replicate my number box, I would just make the capacity 1. You can only hold one number at a time, but you can set the capacity to be whatever you want. Right, so you can say however many numbers can be waiting in that queue at a time, or objects, whatever you're putting in the queue, that's what you specify as the capacity. So in this example, we'll just take a look at 3. Again, if I wanted to, 1 would be analogous to the number box example. Okay, so let's go ahead and run this. And here you'll see that the producer adds something to the box. The consumer retrieves something to the box from the box. Okay, the producer then, oh, still going. Okay, let me let it run out here. And kind of watch what's happening. When you run this on your own machine too, you can kind of play with things and watch it. So the producer adds the 15, the consumer retrieves the 15. The producer adds a 35, the consumer retrieves the 35. The producer adds the 63. Well, the producer goes to sleep and wakes up. The consumer still hasn't taken the 63, but there's still 2 more spots in the queue. So the producer adds a 73. The consumer then wakes up and retrieves the 63. The producer adds a 18, producer adds a 40. The consumer then wakes up, takes the 73, right? Producer adds 59, consumer takes the 18. Producer adds the 81, consumer takes the 40, and so on and so forth. So you can kind of see, again, this back and forth, and at the end here, kind of the producer is done, and so the consumer is, retrieving all the remaining elements. If this were to be a 1, it would just be one space. So there'd be a lot more kind of pausing, waiting going on. But there's no direct calls to wait. Again, it's all happening kind of behind the scenes. It's built into the blocking queue class. So this is a great class. It's super easy to use, and you don't have to worry about the waiting and the notifying, but it can sort of just directly represent this producer-consumer relationship. Now, if we were to change these messages, instead of put and take, let's just quickly take a look at add and remove. So instead of putting, I'm going to add. And instead of take, I'm going to use remove. So again, take will wait, remove will throw an exception when the queue is empty. And then let's just make a smaller queue so we can just be sure to see this behavior. And let's run it again. And here you'll see there are some exceptions. So here we tried to remove, but there's nothing in it. And let's see if we can get the other one. Let's see, still going. And then we tried to add, but the queue was full. So it'll throw an exception if that happens. Okay, now it will continue back because of our loop. Or no, it actually won't. I don't handle that exception in the loop, so it won't throw back. So it will eventually end. But here you see that the consumer tried to take something from the queue and there was nothing there, so an exception was thrown. The producer tried to add a third element to the queue and the queue was full, so an exception was thrown. So if that's the behavior that you want, instead of just waiting, you would use those versions of the insert and remove. You'd use the remove and add. But if you just want the waiting behavior, then you would use the put and the take. Okay, so it just kind of depends what kind of behavior you want in your program. And probably if you were using the version that threw an exception, you'd probably want to catch that exception and deal with it, right? You probably wouldn't want your program to crash. But perhaps there's some other action you want to take when the queue is full or when it's empty. And that version would allow you to do that with a try catch. Or again, you could also use the offer and poll and then check to see, hey, did I get back a null or did I get back a false? And then make some decision based on that. Okay. So that is the blocking queue. Again, it's a pretty great class to support Wait Notify, and this is in reality the type of class you're going to be using for these kind of programs. You're not going to be using, most likely, you're not going to be putting Wait Notifies in your program, but it's good to know how to do that, and it's good to understand that first, so that hopefully, if you understood that Wait Notify example that we did, hopefully the blocking queue is really obvious what's happening, because you can think about behind the scenes. Oh, I know what's happening here. That queue is waiting. And over here, it's notifying the other threads, right? These threads are waiting. These threads are being notified. And you can kind of understand what's going on behind the scenes.